Yeah, really excited to be here today talking about DevOps for machine learning and the process and the best practices and everything that goes around it, around the actual machine learning core itself. So give a really good introduction already. So the one thing I'll just add is that, fun fact, the last time I was here in Toronto was 10 years ago when I was in grad school presenting at an AI conference, way back before it was cool. And so really excited to be back and hope to continue coming to future conferences here. So the core of this talk and really the question that I want you to ask yourself and think about is, how do I deploy machine learning? There's a lot of possible ways that you can do this, and I'm not going to try to convince that there's any one right way to do this in this talk, but just thinking about the question of, if you were to be starting a hackathon project over the weekend, or founding a company, or designing the machine learning infrastructure for a large company, there's a question of how to actually design this life cycle, this system for getting machine learning into production. And the key word there is production. That's the track we're in at this talk. And there's a huge difference between an ML project in the lab or an experiment and actually getting that out into production. A huge number of projects fail because they fail to reach production. We've been hearing that over and over at the talks today. And so the question is how can we improve that? How can we actually make it so that this machine learning and this great work that the data scientists and machine learning engineers are doing actually gets into products and into the hands of people who can benefit from it? So the way that I like to think about this is by analogy with traditional software, by which I mean REST, APIs, web services, things like that, the kinds of software that we've been building for the last 10, 20 years. And the best practices and things like that we've learned over those last 10 to 20 years of building software and how we can apply those to machine learning. So the software development lifecycle can be defined in a number of ways. There's a couple things which are pretty common that you'll see at realistically any business or in almost any project. And again, we're not talking about ML here, we're talking about traditional software. Always going to see Git, CI/CD using Jenkins, GitHub, GitLab, things like that to deploy your code automatically, run tests, things like that. And then the stuff that happens after you write the code and after it gets deployed, monitoring, logging, alerting, those sorts of things. These are table stakes on traditional software. And if you were to go out and try to start a company or start a new project, and you said to your investors or your boss, hey, I don't think I'm going to use source control. I'm not going to use Git. I don't want to use CI/CD. I'm just going to wing it. You get laughed out of the room. But in machine learning, it's actually pretty uncommon to see those sorts of things. And it's incredibly common to see people training models on their laptop using Jupyter Notebook, not even source controlling what they're doing or being able to see the history of how they got to where they got. And so I think that we can learn from this, and we can apply some of these same concepts from traditional software development lifecycle to the machine learning lifecycle. So we'll dive into kind of all of these a little bit more deeply, but just trying to think to ourselves, what would be an analogy for each of these sorts of staples of traditional software development if you wanted to transfer them to the world of machine learning? That's a question we ask ourselves at Algorithmia a lot of, what would CI for AI look like? What are the unique constraints? Why wouldn't you just want to use something like a Jenkins or a GitLab? Or what would you need to do if you wanted to do that? And there's some other qualitative differences of machine learning which you would want to adapt if you wanted to bring some of these best practices into that world. So it's not a perfect analogy. There are differences in how machine learning is done versus how traditional software is developed. And so a big part that I'm trying to emphasize here is that there's a cycle. And it's not just about the code that you write, it's about the code plus the data. So that introduces some additional complexities and some additional sort of links in the software development lifecycle that comes up. But the key here is really focusing on the cycle and the additional steps that come into play as you're doing this. So mostly an excuse to put a cool picture up, but actually even going back to the 1950s, people recognized that there's General Boyd, who was studying dogfighting, fighter jets, and he recognized that the speed of iteration is more important than the quality of iteration. This sounds pretty obvious to a lot of people in this room. It underpins a lot of software development, agile, testing and failing early and often. But this is a really important concept, and it's especially important in machine learning, where we're going to have this constant flow of new data, where there's going to be retraining. The iteration speed can, in many cases, be much faster than in traditional software. So let's break down the phases of the machine learning lifecycle and look a little bit more deeply into each one of them. So it's not usually just going to be one monolithic system. It's going to be a combination of a number of parts that go into it. And there's very different characteristics in each of these phases. So it makes sense to choose the best tools for each part of the job. I think that it's unlikely that there's going to be one end-to-end solution that solves everything for machine learning, everything from the data to the training to the deployment to the management. If you, again, just by analogy, look at traditional software, there's not a lot of examples of end-to-end be-all, end-all solutions that people just use. People use GitHub plus AWS or Heroku plus other monitoring solutions. So I think some people think that there's going to be this whole integrated solution for ML, but I actually think that's not the direction that things go, because you end up wanting to choose the best possible tool for each phase of the job, for each part of the job. And the bigger the project and the bigger the budgets, the more that becomes the case. So I'm not going to talk too much about data. There's a ton to be said, but is outside of the scope of this talk. But the really important thing to recognize is that algorithms, machine learning, without data is generally not going to be useful. So you need to think, as you're designing your lifecycle and your DevOps systems and data systems, that you need to be able to integrate your machine learning in whatever form that is. Sometimes that's a Jupyter notebook or a framework. You need to be able to connect into your data, often always during training, really, and often during production as well, not just the data that's processing through. So training has some fairly distinct characteristics that make it different than maybe traditional software. And one of the big challenges is that it typically happens once. I'm going to wave my hands a little bit there, but there's retraining and things like that. But in the early stages of machine learning, the training is often going to be done by a single person, sometimes on their laptop, usually in an interactive environment because it's exploratory. Stateful isn't exactly like the right word here, but it's not something that you scale horizontally. And that results in very distinct sort of characteristics from more traditional software, where what you care about is scaling horizontally. Doing inference is largely going to be stateless, so you can just blindly spread it out across the many machines or even across the globe and it'll work. So you want different tools and different approaches to each of these two phases. So spent some time thinking about how do you actually go from training into deployment after you've built your model. This is a place where a lot of failures of machine learning happen, where you'll have a data scientist or a machine learning engineer. They worked really hard to do the feature engineering, clean the data, explore the different models and architectures, tune the weights, all those things. And they come back and they say, hey, isn't this great? I have this model that has 90+% whatever accuracy. But if you don't have a way of getting that into production and integrated into products, it's just a science experiment. It's not actually going to be useful. So one of the things that we've talked about at Algorithmia a lot is how do you make that flow from training into deployment as seamless as possible, and also addressing some of those best practice things that I was saying. So one thing that I think is a possible best practice is having 2 Git repos, one for inference and one for training, and being able to track those code bases, because you don't want to just be passing around Jupyter notebooks on your local hard drive or in email in some cases. You want to have a record of these things. And fundamentally, the code that you use for training isn't going to be used in inference. So they are, in a certain sense, different code bases. They might live together, but you want to think about them separately in a certain sense. And going back to the sort of CI and event-driven thinking of things, it's possible to do things like at the bottom of your Jupyter notebook or at the end of your training code, just have a little snippet, and it could be a script or whatever, takes your model, can do some validation, it can do things like hashing to have authentication of the models, so you know that the model generated by this code is the model that you're running in production, and essentially just push that out to whatever your deployment platform is. So this is just one possible way to do it, but it kind of goes along with the idea of traditional software using event-driven and having these pipelines of things that happen after you push the code to run automatically instead of having to do things manually. So there's a couple also unique challenges that come with deployment. Not the least of which is going to be things like specialized hardware. If you're not using GPUs or in the future, ASICs and TPUs and things like that, your machine learning is not going to be running as fast as it could. And if performance matters, then you're definitely going to want to use things like GPUs, which are currently mostly the way things are done in practice. There's a problem with that, though, when it comes to machine learning and why you can't necessarily use the same tools that you use with traditional software as you do for machine learning. So containerization has changed the way that people think about DevOps, but there's a problem with that when it comes into the world of machine learning. And people like to think of Docker as kind of just a very lightweight, very fast VM, but it's not, actually. All the Docker containers on a given machine are going to be sharing the same kernel. And so when you're in a world of machine learning and you need to use NVIDIA GPUs that have NVIDIA drivers which live in the kernel, that abstraction of Docker breaks down. And suddenly it's not acting like an isolated component. You have to think about the hardware and the kernel and the shared environment that these containers are running in. This is complicated by the layers of abstraction that have been built up in order to do what we do today with machine learning. At the bottommost layer is the NVIDIA drivers. There's CUDA built up on top of that, and then the languages and frameworks that you use there. If you're trying to run Docker containers for machine learning and to run an API, the CUDA version has to match inside the Docker container and outside of the Docker container. This leads to a lot of challenges and prevents a lot of deployment systems from being usable, actually, if you want it to be turning your machine learning into an API or whatever. Composability is another really important thing to consider in machine learning that's a little bit unique to this world. A lot of machine learning systems, and this is especially true in natural language processing, is going to be composed of multiple blocks. So a very common example would be vectorizing your inputs before you pass it into some other algorithm. Over time, these are starting to integrate, but if you build a really good NLP processing system in one framework, but you have a different framework, TensorFlow versus PyTorch or versus whatever, then combining them can be difficult. Companies want to standardize on things, but in a field that's evolving as quickly as machine learning is, it can be really hard to standardize when, just last year, TensorFlow was the tool that everybody would go to. PyTorch was barely even 1.0, and now you look at the statistics, and the majority of research is happening in PyTorch, and I would imagine it's quickly catching up in business. So you want to give flexibility to your data scientists and your machine learning engineers to use the best tool for the job and make sure that you can combine them and pipeline them. So finally, management. What are the things you want to do after you deploy a machine learning model? And again, by analogy with traditional software, there's a number of things you want to do, such as logging, alerting, monitoring. But checking things like accuracy. Drawing an analogy to unit tests and integration tests with traditional software. It's a little bit different in the world of machine learning because, well, a unit test for an API or whatever might, if it passes, it's probably going to pass forever going into the future. But in the world of machine learning, it depends not just on the code that you wrote, but also the data and the distribution of the inputs that you're feeding into it. So you have to watch for things like model drift. So you might have built clothing or fashion recognition model that worked great in the summer, and then a couple months later, winter comes around. The training set is not the same as your input as your data distribution now, and so it fails. So you don't want to just run tests when you push new code. You want to run tests continually or on a periodic basis. in order to be able to detect these kinds of regressions that don't necessarily exist in traditional software. So what are some of the problems that we've seen creep in organizations and when people are trying to productionize AI? A really common one that we see is having the right teams. In many cases, a company will hire up a team of data scientists and machine learning engineers, and they'll go off, they'll find some data, they'll do the work of a data scientist, feature engineering, cleaning, building the model, come back with a good, accurate model. And then the question is, who's responsible for deploying that and scaling it and maintaining it and supporting it? And it's a very different task than data science. Spend years learning the art of training models and evaluating all this stuff is a very different task than an engineer, a DevOps engineer in many cases, who has spent their career learning how to make systems that are reliable and scalable and performant. And so figuring out what is that boundary, how do you handle that? Is there a handoff? Or do you just ask the data scientist to be responsible for creating an API for their own work? There's no right or wrong answer. There's going to be pros and cons of any of these approaches, but it's something to think about as you're designing this. And as you're thinking about this, so it's a fairly famous law, Conways Law. Organizations which design systems are constrained to produce designs which are copies of or communication structures of these organizations. Said more simply, if you have different organizations, if you have your data scientists and your DevOps, and that's the structure of your organization, your technology that you build is going to reflect that. And that could be for better or for worse. So it's something to think about as you're designing your data pipelines and systems. Google published this year, hidden technical debt in machine learning. And really the takeaway is that building models is often the easier part. Not always, but it's just one part of a much larger effort that's required in order to successfully deploy and maintain and get value out of machine learning systems. Highly recommended. So ML is in a huge growth phase, which is awesome. There's a ton of interest in it. We're seeing the number of people at conferences increase massively and funding increase massively, which is great for the field. But DevOps hasn't been keeping up. And that's really kind of the point that I want to keep hammering on is, we could do a lot better in the DevOps world when it comes to machine learning. And there's, we've been talking about the challenges, but there's a lot of, the behavior that you want to be able to support for this that is standard for things like APIs is really difficult, again, for machine learning. You might have models that put out that need to handle 1,000 calls a second for a little while and then scale down. That you might also have ones that have very, very long loading, like cold start times, but then maybe run very fast. The way that you schedule these and the way that you manage the auto-scaling and the running of these models is very different and requires a different approach than, again, traditional software. So what are some of the challenges that we've seen? We'll go through a couple of these, but today, deploying ML is economically and technically challenging. There's not a clear path. There's not a standard way that if I took a survey here of 3 people in the room, all 3 would probably have different answers about how they're deploying their machine learning. And a couple of the things that go into that I've been saying in this talk, lack of process, lack of thinking about this in a structured way. It's easy to get it's easy to get proofs of concept. There's a lot of labs out there. There's a lot of companies exploring machine learning. The question is, what do you do after that? What is the life cycle of it? Who is responsible, and from a technological point of view, how is that managed? So there's lack of proper champions. Again, going back to who's responsible, who for which parts of the life cycle. This becomes pretty clear in other types of software. Even just the title DevOps is a relatively recent term that's been introduced as people figure out that it's not just blanket software engineering. There's different disciplines within this, and there's different expertise that you want to build up in those areas. And then there's certainly plenty of opportunity for improved technology. Like I said, a lot of the tools that have been built up over the years for deploying and managing software could be focused more on the task of machine learning. I think there's a huge greenfield opportunity here to ask yourselves, if you're entrepreneurial minded or whatever, how can I take a tool that's been invaluable to software developers in some other context and just ask what would that look like if I wanted to really fine-tune it in order to be applicable to machine learning? Other kind of big takeaways that we've seen over time, don't try to reinvent the wheel. This is another common pitfall that we see companies fall into. They will decide, rather than using something off the shelf or using existing technology, they'll say, hey, we can probably just build that. Maybe repurposing some of our existing deployment infrastructure, or in many cases, there's going to be a team of engineers who just say, that sounds really cool and fun to build. Like, we'll go do that. But we've seen plenty of examples of companies that spend months, and in many cases years, going down this road only to have the project end in failure or not really end up where they want. Unless you're one of the really biggest companies in the world, trying to build your own from scratch machine learning infrastructure is probably not the way to go. There's other considerations looking out for vendor lock-in. There's some giant cloud solutions, things like that. There's trade-offs in those, just as there is with anything. And ultimately, don't try to be perfect. Trying to get improvements where you can and make it, again, an iterative process, and try to make that feedback cycle as tight as possible. So if there's one major takeaway from this talk, I think I've really emphasized it a lot, but machine learning is not the same as production machine learning. If you don't get production, then it's just a science experiment, and we need to get value out of these things in order to sustain all the amazing growth that we've seen in the industry. And we don't need to do this from scratch, though. We don't need to be, it is greenfield, but we're not operating in the dark. It's still a field of software engineering, and there's a lot of lessons that have been learned. There's entire institutes dedicated to, what are the best practices? What are the best tools? What are the best, infrastructure options for software engineering? We can take a lot of those lessons and apply them to our field, and it can make our life as machine learning experts a lot better. So that's what I got. There's some more things to read. The Google paper is really great. I also recommend some of these articles. If you have any more questions, I'll take a few now. Also, don't hesitate to reach out. info@Algorithmia, can get in touch with me that way. And if you have any questions about production machine learning, that's what we do at Algorithmia. So, thank you.
And I do have one question about the model management and versioning. So for example, when we work on, let's say, a Java program and we build an artifact, we use something like a central, like a repository, like a Nexus, like a Artifactory to manage the artifact we build and version it. And so for the model we build, no matter it's due to like data updates or code updates, so how do you manage the model? What are your recommendations for the tools to manage the model?
Yeah, so I definitely think it's important to have, I think there's a lot of benefits to having a central model repository, if I'm understanding your question. I'm not trying to just sell Algorithmia. That is a big part of what we started as, though, is a central place to archive and make discoverable the work that's being done. We see a lot of reinventing the wheel at companies, and sometimes it's things like feature and feature extraction from the data, or just pre-processing data in order to be more useful. In other cases, in other cases, it's things like word-to-vec and vectorization. This is something that, if you have 10 teams doing data science in a company, they're often re-implementing this 10 times. And I think that there's a lot of benefits that you get from having that in one place. There's a bunch of options for how to approach that.
Do you have any open source solution to recommend?
I don't know any open source off the top of my head, but.
Okay, thank you.
Hello, thank you for great presentation. Would you like to mention open standards for predictive model deployment, such as PMML, PFA, Onix?
Yeah, I would love to see a lot more progress on that. we really, I mean, there's a couple really good open source model formats that are starting to get attention. Onix is a good one, PNL is a good one. And I would love to see more of that. The biggest challenge that I've seen with that is that, with rare exceptions, those model serialization formats are not enough yet. You still need to wrap them with Python code or whatever kind of code to do things like processing the input in order to just get it into a matrix form so that you can actually use an Onix model. So one thing I just, personal crusade that I'm on is I would love to see model files that include the entire thing, the entire transformation of the input into the model and then back into the output format that you would want to use.
Thank you. I believe there is a lot of opportunity for open source contributions, especially to Onix. So if anybody is interested, please join Onix project. Thank you.
Yeah, big supporter of that. So yeah, thank you.
Hey, it seems to me that it's kind of challenging to reconcile the difference between, there's this tooling gap and don't build it yourself, and don't reinvent the wheel, and don't get locked into a vendor. Do you have any examples of something that kind of threads the needle properly, or where you've seen the balance properly allocated between those extremes?
Yeah, I mean, I think you're hitting on it right. There's a spectrum of options. There's the full cloud provider lock-in, SageMaker, things like that. There's full open source plus some rolling it of yourself. Again, kind of selfishly, Algorithmia, I think, tries to thread that needle in the sense that we're multi-cloud. We can deploy to AWS, we can deploy to Azure, we can deploy to VMware. So that gives a lot of flexibility in that sense. I think over a long period of time, the open source infrastructure tools will get there. And for the time being, I think that even though they're advancing really quickly, they still fall short. It takes a long time for open source software to get enterprise ready. So that's kind of our thesis of kind of how we're positioning ourselves. So yeah, I don't know.
Got it. Thanks.
Question about production side of your deployment. So model can drift very fast. So what is your recommendation? How to monitor? How to set maybe thresholds? To go back to rebuilding code.
Yeah, I think that depends a lot on the problem domain more than anything. We see people wanting to do retraining or monitoring on an hourly basis, on a daily basis. But there's probably many situations where it doesn't need to be that frequent. You could get away with monthly or weekly or yearly in some cases. I think daily is probably the most common sort of period to run tests and reevaluate models, and often concurrently with retraining, which again, I feel like daily is what I see the most commonly, just anecdotally.
Should be retraining automatic in this case?
Sorry, what do you mean?
So basically, you have model which deployed, but you can build another block which train models in parallel and deploy it automatically. So is it way to go, or it should be human intervention?
Again, I'm going to say it probably is fairly vertical specific. It depends on the use case. I think that it also depends. Do you have labeled data? Do you have unlabeled data? When can you do the retraining? The example that he mentioned of wine. I built a model. I trained it on the images. But if a user, a user takes a picture and we send a recommendation, we don't necessarily know what the correct label for that is on a nightly basis. We might need to send that over to Mechanical Turk, and so it might be on its own schedule. I don't think that there's sort of a blanket rule for that.
Yeah, so labeling can be a human intervention actually in this case.
In many cases, yeah.
Okay, so it should be background to make it production, sort of several business analysts combined with data scientists who labeling in time to make it production, really production.
Sorry, I'm not sure I understood the question.
So it looks like to make it really production, it should be whole team working to prepare data to update models in time. Otherwise, model drifting, and you don't have resources to update model.
Yeah, I mean, yeah, the challenge of cleaning the data and maintaining the data doesn't end when you're done your first round of training. I mean, that's an ongoing process for sure. And hopefully you can detect that automatically in some cases using model diff detection and accuracy detection. But I do agree that it's something that you need to be proactive about.
Hi, I have a quick question more related to the people who are currently studying everything related to machine learning, AI, and how we can start incorporating this mentality of DevOps since the very beginning. And I'm asking this because, yes, I'm studying things related to machine learning, but I've never been exposed to projects related to something in deployment. In your opinion, what is a good initiative that universities, educational institutions can pursue in order to bring those two things together? Because I've seen this void, and I really don't know how to work towards it.
That's a really good question, and it's something I think about a lot. I mean, it's actually kind of funny that I was doing a PhD in AI and machine learning, and not once did somebody even mention Git. Like, nobody even mentioned source control. Like, nobody thought about, like, how you run it or how you actually get it, in the real world. And that was honestly one of the things that frustrated me when I was back in academia, was just this like the chasm between the work that people are doing in machine learning and pushing the state of the art and building these models, but not actually getting them into the hands of people and companies and projects that could really benefit from them. And that's why one of the reasons why I'm technically on a leave of absence from academia right now, because that's one of the reasons we built Algorithmia was, how can we get this great work that's being done into the hands of more people. So I think that there's a lot that universities could be doing. I mean, it's tricky because a university is meant to be a place of pure learning, and it's not just about the applications and the use cases. But I do think that there could be a lot more crossover from the software engineering institutes with the rest of the CS departments. At Carnegie Mellon, actually, the Software Engineering Institute was completely separate college from computer science and all that. And I think that that's a lost opportunity to have that separation.
Are there any good industry practices for when you don't have ground truth?
Sorry, say again?
Are there any good industry practices when you don't have ground truth available to you?
You mean like you don't even have the data labeled to
Yeah,
begin
so you
with?
don't have target available. So we deploy a lot of reinforcement learning apps. And we are working towards explainable RL. So there's a lot of use cases where we don't have access to ground truth. So I was wondering, what are some of the things that you guys use?
Yeah, so that's something I didn't really have time to get into as much in the talk, and I kind of focused on some of the more simple of the machine learning use cases, things like vision and natural language processing. Reinforcement learning and some of the things of that nature have an even different life cycle on their own. And so they require thinking about in kind of different ways. I think that there's the basic thesis of, how can we add more best practices to it still applies, though, even in that world. Best practices like, snapshotting versions of the model as it's going and, keeping track of those. And in many cases, even, using things like semantic versioning, which doesn't always translate totally cleanly, but, just having snapshots of the reinforcement as it's going is something I think you can, again, look to traditional software and see examples of how that's been done before. And I think that there could be a lot of interesting opportunities there if somebody wanted to explore.
All right, thank you.
Thank you.